Welcome to This Explainer. Today, we're jumping right into the deep end of the rapidly escalating cyber arms race. We are going to map out exactly how artificial intelligence is fundamentally rewiring the worlds of both hacking and cybersecurity. If you've been paying any attention to the tech space lately, you know things are shifting at breakneck speed. Well, today we're moving way past the theoretical warnings and looking at the hard data of what's actually happening out in the wild right now.
We've got a packed agenda covering the entire battlefield. We'll start with the first AI Zero Day, look at autonomous attack agents, hacking the supply chain, the new hacking economics, and finally, wrap up with the AI counteroffensive. Let's get to it. All right, Section 1, the first AI Zero Day, moving from theoretical fears to concrete reality. This quote from the Google Threat Intelligence Group basically confirms our absolute worst fears. A prominent cybercrime syndicate successfully developed a working zero-day exploit, meaning a software flaw completely unknown to the original developers using artificial intelligence. Their end goal? To bypass two-factor authentication on a popular web-based administration tool in a massive exploitation event. Now, thankfully, proactive discovery by defenders seems to have stopped its use at scale. But the watershed moment is officially here, folks. AI is successfully discovering and weaponizing completely unknown vulnerabilities. Now, what's genuinely fascinating is how the AI found this. It didn't uncover some standard memory corruption bug or an input sanitization failure. Nope. Instead, it reasoned through the code to spot what's called a semantic logic flaw. You see, traditional static analysis tools and fuzzers are built to detect system crashes, which means they constantly miss these high-level human logic errors. But frontier AI models, they are incredible at contextual reasoning. The AI effectively read the developer's intent and correlated the two-factor authentication logic with the totally contradictory hard-coded exceptions. So, since the attackers didn't exactly leave a calling card, you're probably wondering, how did Google's threat team even figure out that an AI wrote this Python script in the first place? Well, it turns out the script was absolutely loaded with classic large language model hallmarks. We are talking about a totally hallucinated CVSS score. That's the standard system used to rate vulnerability severity, right alongside highly annotated textbook Pythonic formatting like a clean color ANSI class. Let's be real, human hackers just don't waste time putting pristine educational documentation into a malicious exploit. The AI wrote it exactly how it was trained to write textbook Python, basically acting like a robotic teacher's pet rather than a stealthy hacker. Moving on to Section 2, autonomous attack agents. This is where malware starts making its own decision. Take the Android backdoor known as Prompt Spy, for example. This thing operates with alarming autonomy. Attackers are literally offloading their operational tasks directly to AI for scaled adaptive activity. Prompt Spy uses an autonomous agent module to essentially see the victim's screen. It grabs the visible Android interface, converts it into XML text data, shoots that data over to the Gemini 2.5 Flashlight API, and then receives a JSON payload back with exact spatial coordinates. From there, it executes a simulated physical click or swipe. It's navigating the victim's device completely without human supervision. And get this, to protect itself, the malware uses real-time AI spatial awareness to essentially throw up a protective, invisible shield right over the uninstall button. If a victim tries to delete the app, the malware identifies the coordinates of the button and intercepts the touch events, making it seem like the phone screen is just unresponsive. It's a ridiculously resilient defense mechanism. Furthermore, when we compare traditional evasion to AI evasion, we're looking at a massive leap in sophistication. Instead of just packing code to hide signatures, AI augmented threats like canfail and longstream generate huge amounts of coherent but totally inactive decoy logic. For instance, longstream actually checks the system's daylight savings time status 32 times in a row. I know, it sounds totally absurd to us, but to a traditional security analyzer, all this repetitive, benign activity perfectly camouflages the malicious code hidden right underneath it. Okay, Section 3, hacking the supply chain. Infiltrating the AI software ecosystem itself. Threat groups like Team PCP are going straight for the dependencies. They've been compromising PyPI packages and submitting malicious pull requests targeting AI gateways like LittleLM and agent ecosystems like OpenSCLAW. Why are they doing this? Because it's the perfect initial access vector.
A single malicious AI skill can suddenly steal AWS keys, extract GitHub tokens, and deploy credential stealers like SandClock directly from CI/CD build environments, which are essentially the automated assembly lines where our software is made. From there, they just pivot into the broader network and drop ransomware. The worm, known as Shai-Hulud, is a prime example of this rapidly expanding threat surface.
Section 4. The new hacking economics. Let's talk about why smaller targets are suddenly at massive risk. We really have to ask ourselves, why does any of this matter to the average business or individual? Why the sudden spike in these automated supply chain attacks?
As Guillermo Rauch, the CEO over at Bristol, pointed out after a recent security incident involving a compromised AI customer service bot, the velocity of these attacks is just staggering. AI gives hackers an unprecedented speed and depth of understanding. And this massive acceleration, it completely flips the traditional economics of cybercrime on its head. Historically, complex cyber attacks were super expensive and time-consuming. It really only made economic sense to go after huge, high-value enterprise targets. Going after the long tail of smaller businesses or individuals used to result in a negative return on investment for the hacker. It just wasn't worth their time. But now, with AI automating the vulnerability discovery, writing the exploits, and orchestrating the actual attack, the cost of hacking has plummeted. By drastically lowering the effort required, AI makes it highly profitable to attack thousands of smaller, lower-value targets all at the same time.
Finally, Section 5, the AI counteroffensive. Your AI versus my AI. I promise, it's not all doom and gloom. Let's dive into the ultimate counteroffensive where the good guys are fighting back. The paradigm we're entering now is essentially your AI versus my AI. This quote hits the nail on the head. There is a massive structural economic moat in AI development. Major tech labs and state actors have the billions of dollars required for the compute power, the massive data centers, and the research teams needed to build frontier models. Rogue malicious actors and cybercrime syndicates just simply cannot afford to train models of this caliber. Because of this, defensive AI should theoretically outpace the offensive capabilities of rogue actors, simply because defenders have access to vastly superior tools. And we are literally already seeing this play out with a new lineup of defensive heavyweights. Google's Big Sleep and CodeMender are actively finding unknown zero days and automatically patching them. Anthropic gave their unreleased Mythos model to select security partners, and it successfully discovered a 27-year-old vulnerability in OpenBSD, an operating system historically renowned for its airtight security. Meanwhile, OpenAI's GPT 5.5 Cyber, which is part of their Daybreak initiative, is out there right now automating security detection and validation. These frontier models are scouring code to patch decades-old vulnerabilities before hackers even know they exist. So the arms race is unequivocally here. Attackers are moving with terrifying velocity, exploiting the supply chain and deploying entirely autonomous agents. Yet at the same time, defenders are armed with the most powerful frontier models ever created. The big question I want to leave you with today is this. As the barrier to entry for cybercrime completely plummets and the volume of attacks on smaller targets skyrockets, is your organization's defense posture actually ready for this new era of automated AI-driven warfare? Thank you so much for joining me for this explainer. And hey, keep your defenses sharp.